Okay, here we are looking at a question involving calculus and position, velocity, and acceleration, and kind of looking at what's happening to this function or this particle as it's moving along what they call the s-axis, which is it's going to give its position at any particular time. And so the s-axis is it's one-dimensional, and I think that can be part of the weirdness about this. But you have this equation, s of t equals t cubed minus 9t squared plus 15t. And so you want to kind of give it some thought as to what that means. So let's just write that. We have s of t is equal to t cubed minus 9t squared plus 15t. And this is going to be a position in meters. So if we only want to think about the the s-axis, well, s is going to be in meters then. So like you might have 0 and then 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters, 7 meters, 8 meters, etc. So, so this will be, let's just do 2, 4, 6, 8, and this is all meters. And then we could find, like obviously s of 0, we could find some times here, some positions. At 0, we're at the starting place. And maybe s of 1, if you plug 1 in, you're going to get 1 cubed minus 9 plus 15. So that's, let's see, negative 8 plus 15, so that's at 7 meters. So after 1 second, if we were going to draw this, we start at 0, but we travel 7 meters after 1 second. So when t equals 1, we've gone 7 meters. Okay, now let's look at let's look at s of 2. S of 2 is 2 cubed, which is 8, minus, let's see, 2 squared is 4 times 9, that's 36. So 8 minus 36, which is negative, and then you put 2 here, let's just do it here. So, okay, so it's 8 minus 36 plus 30. So this is 30, and negative 36 makes negative 6 plus the 8. So then you're at 2 meters. So somehow after 2 seconds, you're back here, right? This is where you are at t equals 2 seconds. You're back at 2 meters away from the starting point. So you must have turned around at some time. You must have turned around. If you look at s equals 3, you could figure out where you are at that time, and my little brain is not working too well this morning, so maybe we'll just go ahead and put this into our calculator, and we can put some different times in to have it work better. So let's see. So we'll go into y equals, and if we put the function in, we go to the table and we just put in, obviously 0, 0, 2, we put in 1, let's see if I got that one right. Yeah, we got 7 at 2, we were at 2 at 3, we're at negative 9, so it's kind of weird. And then at 4, you're at negative 20, and at 5, you're at negative 25, at 6, oh wow, you're at negative 18. So it looks like you might have changed again because you were at negative 25 and then you turn back and you're at negative 18. So it looks like there's some interesting things going on here. So obviously, though, really these negatives are kind of weird. I don't know that they really make sense for the actual problem situation. But what I'm trying to get you to see is that it does look like we're kind of moving along the s-axis here. Okay. So I'll just delete this right here, and we'll go on to answer the questions as they present themselves. So our big question is, all right, well, at 1 second, we're at 7 meters. At 2 seconds, we're at 2 meters. So we must have turned around. Where did we turn around? Well, it turns out you turn around, when you turn around, your velocity at that instant that you turn is going to be 0. So you're going to have positive velocity when you're moving to the right, and then negative velocity when you're moving to the left. And at the moment that you change velocity or change direction, the velocity is going to be 0 at the moment you change direction. So the question is, find the body's acceleration each time the velocity is 0. Well, this is also going to help us understand where we change direction, what happens, at what point is the velocity 0, is also going to be something that we're going to be able to figure out from that first question. All right, so if s of t is equal to t cubed minus 9t squared plus 15t, remember the velocity is equal to the derivative of the position. So in this case, it's going to be 3t squared minus 18t plus 15. And we want to see when the velocity is equal to 0, because that's the question. So we'll set that equal to 0 and solve it. 3t squared minus 18t plus 15 equals 0. So I can factor a 3 out. I get 3t squared minus 6t plus 15 equals 0. And this one factors nicely as t minus 5 times t minus 1. And so you get either t equals 5 or t equals 1. Those are the places when the velocity equals 0. All right, now the question is find the body's acceleration each time the velocity equals 0. So the way we would do that is we would go ahead and calculate acceleration. Well, remember, the acceleration is equal to the derivative of the velocity. And so the velocity was 3t squared minus 18 plus t plus 15, so this is going to be, the derivative of that is 6t minus 18. So we want to know at the times when the velocity is 0, which is 5 seconds and 1 second, what is the acceleration? So all they want on this question is for you to find a of 5, which is going to be 6 times 5 minus 18, which is negative 12. Meters per second squared is the unit for acceleration. And then a at 1 second is going to be 6 times 1. Okay, I'm sorry, I made a mistake there, didn't I? I meant this is positive. This is 30 minus 18, which is, of course, positive 12. And then a of 1 is 6 times 1 minus 18 equals negative 12 meters per second squared. Okay, so our acceleration is at 5 seconds is 12 meters per second squared, and at 1 second it's negative 12 meters per second squared. All right, now let's see what else is happening. The next question is find the body's speed each time the acceleration is 0. Okay, well, speed each time the acceleration is 0. So find on B, then, we have to do two things. We have to figure out when the acceleration is equal to 0, and then we have to find the speed at that moment. All right, so for part B, our acceleration function, a of t, was equal to 6t minus 18. So if we want to figure out when acceleration equals 0, we just set that equation equal to 0, and so we get 6t is equal to 18, so t equals 3 seconds. Now, speed is the absolute value of velocity. So speed equals the absolute value of velocity. So the speed when the acceleration is 0 is really asking for the absolute value of the velocity at 3 seconds. All right, which we already computed, or no, we haven't computed that yet. So let's look at the velocity. What was our velocity formula? It was 3t squared minus 18t plus 15. So we just need to find that answer. Okay, so we're going to do the absolute value of 3 times t squared. Here our time is 3 seconds, minus 18 times the 3 seconds, because it's 18t, and then plus 15. And this problem is really annoying because if you calculate that out, you actually get the absolute value of -12, which of course is 12 meters per second. So I guess this problem, the answer is 12 or -12 for all three parts, which is really weird, but okay. And then finally on part C, it says find the total distance traveled by the body from t = 0 to t = 2. Okay, now you have to worry about whether the object turned around at all in that time interval from 0 to 2. And by looking at this, you have a suspicion that it probably did in fact turn around at a particular time. And the time that it, or the place, well, no, the time that it can turn around is when the velocity equals 0, because at that instant something happens and it changes its direction. Perhaps you want to check and make sure that that in fact does occur. So if you look at your velocity when it's equal to 0, we have at, obviously, well, this would be like 0 to t = 0 seconds. And then let's look at 1 second, and then let's look at 5 seconds. So this is seconds. And I'm going to be thinking about what the velocity is doing, okay? Meaning, what is the direction of the velocity? If the velocity is positive, the particle will be moving to the right. If the velocity is negative, the particle will be moving to the left. So when I pick a number like 1/2 and I plug it into this equation, into the velocity equation, so if I do v of 1/2, all I want to know is that positive or negative? Well, let's see, that's going to be 3/4 minus 18 times 1/2 is 9 plus 15. So this is clearly a positive number, which means that it is moving, so from 0 to 1/2, it is moving to the right. Sorry, from 0 to 1, it's moving right. It's moving to the right for the first 1 second. And that goes along with my picture up here. It's traveling, it actually travels, we know that it traveled 7 meters in the direction away from its starting point. Now, between 1 and 5 seconds, what is it doing? Well, let's pick a velocity, let's pick a time, like 2 seconds. If you put that into your equation for velocity, 3 of 2 squared, 3 times 2 squared minus 18 times 2 plus 15. All right, so this is going to be 4 times 3 is 12, plus the 15 is 27, but then it's minus 36. So this is less than 0. So in this interval, it's moving to the left because it's negative, and a negative velocity means the opposite direction. So at this instant, at 1 second, it actually changes direction. So that tells us, if we're thinking about this particle, that here we are, remember we traveled from 0, let me see if I can get a different color, from 0 to, from 0 meters to 7 meters, and then at 1 second, we turn around and then we travel to the left. And we know that at t = 2, we're back at 2 meters. So the question on part C is, how far, or what is the total distance traveled? Well, you went 7 meters to the right, and then you came back around and you went 5 meters to the left. So your total distance traveled is 7 plus 5, or the 12 meters. So that's how you can visually think of that. On part C, total distance traveled, you know, at s of 0, you were at 0. S of 1, which is an important point because at s of 1 the velocity is 0, you're at 7 meters. And then s of 2, and the reason I chose 2 is because they want to know the distance traveled on the interval from 0 to 2 seconds. We're back at 2. So 2 meters. So what you want to think of is, okay, here I went 7 meters to the right. And then from here, from 1 to 2 seconds, I went 5 meters to the left. But my total distance traveled is the 7 plus the 5, or 12 meters. So it's kind of funny because this problem has the number 12 in all three of the questions, but in each question the 12 represents something different. In C, it's the total distance traveled. In B, it's the speed when the acceleration is 0, so it's 12 meters per second. And then in A, it's the acceleration when the velocity equals 0. So I think they're just being cute there. Okay.